Hello again. So this is the part 2 of the homework 3 where we are gonna change the outputs from LEDs to the 7 segment display on the DE1 SoC board. So as we know that it's a 4-bit cross 4-bit multiplier which has the maximum decimal number as an output as 225 for 15 cross 15. So we would need seven, three, three displays of the 7 segment display. So this is the Verilog code where we make the calculation and then we just send it to the decoders one. So we just get the inputs from the switches. So switches are remaining the same, just the outputs are going to change. And then once we get the outputs in the binary form, so we then convert it into the BCD form, and then we also assign it to the hundreds, tens, and ones, which are the three digits that we are going to see on the 7 segment display. And then getting these BCD digits, then we are going to convert that to the 7 segment display code. So using this code. So once we are done with the coding part and then with the IP part, we just had to add the same IP components that were used for the part 1. So I've just added it here. And then we just click on the run compilation. So this is gonna check for the compilation. It is gonna take some time, so we'll just be waiting. So in the meantime, we'll just look at the other parts of the part 1 assignment, which was also doing these optimizations for the speed and area. So this is the output that I've got from the applications report after compilation. So, and then this is the discussion part, which is how the numbers are changed and why. And then this is the part which we are gonna look at this demonstration video. So I've also ran the compilation report once. So this is the data that I've got. It has used 94 ALMs, 185 ALUTs, 0 BRAMs, 0 DSPs, and the frequency was again calculated using the propagation delay, which came out to be 26.157 nanoseconds from the input pin switch 7 to the hexadecimal 1 of 2. So it came out to be 38.23 megahertz. So we just look at this, it says 34%. So once we are done with the compilation report and stuff, so again we are going to program it to the D1 SoC board, and then we are going to look at the verification part. And we have also made the pin planner assignments, and we have also assigned few pins for the EXA parts. So it's running on 58%. So the compilation is done. So if you just look at the fitter, so this is the design used 94 ALMs and then 0 BRAMs and 0 DSPs. For the ALUTs, we're going to look at the resource section. So it says 185. And then again for the timing, we are just going to look at the timing analyzer and then create timing netlist. And then we'll be looking at the datasheet reports. So at this, we are going to look at the maximum number, which is the maximum delay that was available. So the number which was maximum was 26157, which is for this part. So once this is done, we are going to look at the programming part. So again, we are going to just look at the hardware setup, which is very good. And we again click on the auto detect, add the output SOF file. This is all done. So we just click on the start. So as we can see, the progress is 100% successful. So we'll be looking at the other video where I'll be demonstrating it on the board. Yeah. Hello again. So in this part, we'll be looking at the board's verification. So we have programmed the board using the application, and then it was 100% successful. So we'll be using the test cases now. So just let us just do the 10 cross 8, which should be giving the output as 80. So 10 is 1 0 1 0, and then 8 is 1 0 0 0. So it will be this. So if you just look at this, 1 0 1 0, then 1 0 0 0, where we got the output as 80. So we'll be doing 15 into 12. So 15 is 111, and then coming to 15 into 12, so 12 is 1100. So the output is 180. As we can see, it's on the 7 segment display. And then we also do the maximum number, which is 15 cross 15. So we can see at this, it says 225, which was the maximum number we could get as the output. So this successfully implements the design, and it is also verified on the D1 SoC board. Thank you.